Hey guys, here to do a little more factoring with you. You're probably wondering, is this stuff ever going to end? We are getting close to it, I promise. Today we're going to look at two special cases that we have. The first special case that we have is the perfect square trinomials. Okay, so with these ones, what you're looking for is, are my first and last term perfect squares? If they are, then there's a good chance it's a perfect square trinomial. It's not a guarantee, but 99% of the time it will be. And the nice thing about perfect square trinomials is they're always going to factor into the same thing. Okay, so for example, with this one, we know that both the signs would be positive. And then what you just want to do is you just want to take the square root of each piece. Okay, so the square root of a squared would be a, square root of b squared would be b. It's the same thing in both sets of parentheses. And then sometimes you will also then see that written as a plus b squared. I don't care which way you leave your answer. Some kids like to leave it like this, some like to leave it like that. It does not matter to me. I will accept it both ways. And then it can also happen when they're negative as well. Okay, it would really just turn into then both of your signs being negative. And then again, if you would wanted to write it, okay, in the other form, you could do that as well. Okay, but a perfect square trinomial is where you end up with the same thing in both sets of parentheses. Okay, so we're just going to look at a few of those here today. And then we'll also have different squares, but we'll look at that after these ones. Okay, so the first one you've got is you got 64x squared minus 16xy plus y squared. Okay, and we'll go ahead and throw b on here as well. 49x squared plus 70x plus 25. So again, for you to have this, the first term and the last term have to be perfect squares. Okay, which they are here. Okay, so I'm going to look and check that one first. Okay, positive here, negative here, so both signs are negative. Square root of 64x squared is 8x. Square root of y squared is y. So you would double check, you get negative 8xy, you'd get negative 8xy, would give you the negative 16xy in the middle. Again, completely up to you if you want to write it that way or the other way, it doesn't matter to me. Same thing here, both of them are perfect squares. Okay, so we go ahead then and look at this. Okay, square root of 49x squared is 7x. Both the signs are positive here, so they're both positive here. And then square root of 25 is 5. So again, same thing in both sets. Double check it. You get 35x. You get 35x. Those add to 70, so it does check out for us as well. Okay, so really it's kind of a shortcut. If you didn't recognize the shortcut and you ended up doing it, you know, writing out all the factors and that stuff, that's fine. Okay, you'll still get the same answer in the end. Just trying to, again, if you notice they're perfect squares, at least look for this first. Okay, just to, again, save yourself a little time. Okay, actually I'm going to leave D off here because we're going to need a little more room for this one. So I've got 2x squared minus 24xy plus 72y squared. You still need to look for GCFs here as well. So you do have a GCF. Okay, a 2 can be pulled out of everything, so I need to pull that out first. Okay, after I've taken out the GCF, I can look to see if I have perfect squares. I do. Okay, perfect square here, perfect square here. So that means I'm going to look for my pattern. Okay, both signs would be negative. X squared would just be x and x. Square root of 36y squared would be 6y and 6y. So if you check, you'd get negative 6xy, negative 6xy. The combination of that will give you negative 12xy. And one last one. is 16x squared plus 80x plus 100. Now some of you might go, hey look, they're both perfect squares. You're right, but GCF has to happen first. If you have both of them, you always do GCF first. Okay, so I need to pull a 4 out first. And after you do that, you'll notice you still have perfect squares. Okay, so it didn't ruin what we were doing. We just have to make sure we do that step first. Both signs are positive. Square root of 4x squared is 2x. Square root of 25 is 5. Again, double check. You'll get 10x and 10x, which does give you the 20x in the middle. Okay, so that's the first shortcut. Okay, so that one just kind of allows us to speed up the process of factoring a little bit so you don't have to sit there and write out every single factor. Okay, the next one is something brand new. It's what if I only have two terms? Okay, this one is called difference of squares. And it's just like it sounds. Difference means it's going to be subtraction. Squares mean both terms have to be have to be perfect squares. The big thing here is it's only going to be two terms. We want the middle terms to cancel out, so there's only two terms. Okay, so difference of squares would look like something like this. Okay, where you'd have a squared minus b squared. Has to be subtraction. If it's addition, this does not work. These both have to be perfect squares. If they're not, it does not work. Okay, so it is a very specific type of factoring. And what we do when we get this is we're still going to do square roots. So square root of a squared is a, square root of b squared is b. The difference comes in is the signs will always be opposite. By having opposite signs, it will cancel those middle terms out, the reason we don't have one. Okay, so when you're working with difference of squares, always, always, always have to have opposite signs. Okay, it doesn't work unless you do. So first one we got here is we got 4x squared minus 9. Okay, so if we look at this one, and actually I'll go ahead and throw b on here as well. Okay, so you'll notice you do have a subtraction sign. They are both perfect squares. Then we can factor difference of squares. Always opposite signs. Don't care which one goes first, which one goes second. Okay, square root of 4x squared would be 2x. Square root of 9 would be 3. And notice when you check positive 6x, negative 6x, that's why they cancel. That's exactly what needs to happen. Okay, for b, same idea. You have a subtraction sign and you have perfect squares. Okay, so same idea. Take the square root of 44x squared. Take the square root of 25. Okay, the middle ones will give you a positive 60 and negative 60, so they will again cancel each other out. All right. Now, we also can have GCFs with these as well. Again, doesn't matter what type of factoring we're doing, the GCF is the very first thing that you look for every single time. Okay, so we'll have 12x squared minus 3. So first thing I have is a GCF of 3 that I need to take out. Okay, so if I divide each by 3, I'll get 4x squared minus 1. Notice I now have difference of squares. Subtraction sign, both perfect squares. Okay, so I'm going to have my two sets of parentheses, opposite signs, a 2x, and square root of 1, remember, is just 1. Okay, again, middle terms will cancel out, which is what we need to happen. Okay, two more here. So again, no GCF this time, both perfect squares. So we'll have a 4x and a 4x, plus and minus, 9 and 9. Again, middle terms will cancel out as well. All right. And one last one here for you guys today. Notice we do have a GCF here of 5, so I will go ahead and take the 5 out. Okay, after we take out our GCF of 5, we are left with our perfect squares. So I'll go ahead and have my 2 sets of parentheses, opposite signs, x and x, 8 and 8 for that one. All right. So that's your 2 special cases. You got your perfect square trinomials, and you've got your difference of squares. All right. Again, make sure you do the assignment under the daily agenda, not the one that's in your packet. We do make some changes to that based off, just not being in school and stuff. So we have one more day of factoring to go over, and then we will be done with our factoring and actually be wrapping up Chapter 8 here pretty shortly as well. So we'll be looking at another quiz and possibly a test. I have to talk to Mr. Lynch yet about that. All right, otherwise, have a good one.